we have the coordinate system, okay, and then we have a vector coming this way, okay, and we have another vector coming this way, okay, and let's say that this angle, let's call it θ1, is going to be 45 degrees. Let's call this angle θ2, and it's going to be 45 degrees. This vector, let's call it vector 1. It's going to be 3 meters per second. It's going to be a velocity. And this vector, which is going to be v2, is going to be 1.5 meters per second. So we have to break them down. We have to break down v1. It has to be in the v1 in the x direction, and another one which is going to be v1 in the y direction. And then we have to break down the other one. The other vector is going to have one component which is going to be this way. It's going to be v2 in the x direction. It's going to be a negative one, and v2 in the y direction, which is going to be a positive one. So we got to break them down, and then we have to add this guy with this guy, and this one with this one. So we have to have the summation of the vectors in the x direction, which is going to be v1 in the x direction. It's going to be minus because he's going to go the other way. It's going to be, this is the negative side, this is the positive side, this is the negative side, and this is the positive side. So he's going to be v1x minus v2x. And the summation of the vectors in the y direction is going to be v1 in the y direction plus v2 in the y direction. So this is how we get all the vectors in the x direction and all the vectors in the y direction. Okay, so we have that v1 in the x direction is going to be v1 cosine of 45 degrees, which is going to be 3 meters per second times the square root of 2 over 2. So that's going to be equal to 2.12 meters per second. And then we got v1 in the y direction, which is going to be v1 sine of 45 degrees, and it's going to be the same, and it's going to be 2.12 meters per second. Okay, and then we're going to have v2 in the x direction, which is going to be minus 1.5 meters per second times sine of 45. Okay, sine of 45 degrees. So this is going to be minus 1.5 meters per second times square root of 2 over 2. And that's going to be equal to minus 1.06 meters per second. And then we have v2 in the y direction, which is going to be minus 1.5. It's going to be plus meters per second times the sine of 45. Okay, sine of 45 degrees. So v2 in the y direction is going to be 1.5 meters per second times square root of 2 over 2. And that's going to throw you, so v2 in the y direction is going to be 1.06 meters per second. So we got this guy. V1 in the y direction is this guy over here. And V2, okay, and we got this one over here, right here, V2. And we got everybody, okay. So let's go back and plug these guys in. So the summation of the vectors in the x direction is going to be V1 in the x direction, which is 2.12 meters per second, minus V2 in the x direction, which is 1.06 meters per second. And that's going to throw you the summation of vectors in the x direction is going to be 1.06 meters per second. And then the summation of the vectors in the y direction is going to be V1y, but whose V1y is going to be 2.12 meters per second plus the summation of V2y. So V2y is going to be 1.06 meters per second. So the summation of the vectors in the y direction is going to be 3.18 meters per second. And now to get the magnitude of the velocity, resultant velocity is going to be Vx to the square plus Vy total to the square. And we can, okay, we can do it better. We can put it like this. It's going to be the summation of the vectors in the x direction to the square plus the summation of the vectors in the y direction to the square, and then you got to get the square root of this. Okay, so the magnitude is going to be equal to, well, we got the Vx. Vx is going to be this guy right here. So it's going to be 1.06 meters per second. And we got to square these guys plus summation of Vy. Summation of Vy is this guy right here. So it's going to be 3.18 meters per second. And we got to square that guy, and everything has to be elevated to the square root. So your magnitude is going to be, if you do all this junk here, it's going to be 3.35 meters per second. Okay, there you go. That is the magnitude. And we still have to get the direction, the θ3, let's call it, which gives direction. So let's calculate that one. So we will need more space to do that. So here we go. Let's get more space. Okay, let's clear this board. Here we go. And now we have that our vector resultant. Okay, we have our resultant. It's going to be some, so what do we got here? So we have our Vx, this comes this way. Okay. And then we have our Vy that comes this way. Okay. And then we do have our resultant. Okay, it's going to come this way. Then it's going to go down this way. And then it's going to come, oh, okay. It's going to come this way. Okay. And the resultant is going to go this way. So we're going to have here the angle θ3, and this is going to be the summation of the vectors in the x direction, and this is going to be the summation of the vectors in the y direction. This is some, okay, so we got this guy, the summation of the vectors in the x direction was 1.06 meters per second, And this guy over here, the summation of the vectors in the y direction was 3.18 meters per second. Okay, but we still have to get the, and we do have the magnitude. The magnitude of this one is 3.35 meters per second, but we still have to get the angle theta. Let's call it theta 3. Okay, so theta 3 is going to be the arctangent of the summation of the vectors in the y direction over the summation of the vectors in the x direction. So theta 3 is going to be the arctangent of we got it's going to be 3.18 meters per second over the summation of the vectors in the x direction, which is 1.06 meters per second. So you cancel these guys, and theta 3 is going to be equal to 71.5 degrees. So we got this guy, which is 71.5 degrees, and that's the direction. Okay, that's the direction of the vector. Okay, of the vector. There we go. And we have done addition. This is addition of the vectors. Okay, so we got that. And now we have finished.